Okay, so hi everyone. Today we will talk about Python in automotive. I am Fursenko, currently working in Global Logic as a software engineer in automotive. Have experience more than 4 years in it. Okay, let's move. Today we will talk about Python in automotive, and we will cover those topics. We will talk about automotive software, about ECUs, base system, infotainment, tools, and programming languages in automotive. We will talk about how is car programmed, like workflow, and we will talk about creating and downloading the software. We will look at Python as a language with a brief introduction and pros and cons, and we will see the role of Python in automotive industries, as well as seeing like code analysis and names of famous automotive repositories. Great. Automotive software consists of 4 main parts. First one is electronic control unit. Next is base system, vehicle control unit, infotainment, and tools. Electronic control unit is a small device you can see on the pictures. It just sits in a car and does some functions. So modern cars contain more than 100 ECUs, all of them covering different electronic functions of a car, from important functions like steering control or engine, to comfort ECUs like powering windows and seats, and to safety ECUs like emergency braking and airbags. So ECU typically contains a chip that runs its own software, and it's connected to its own power and communication lines. So ECU receive inputs from different sensors depending on a function. For example, if you have ECU which is responsible for controlling the car locking system, it could receive inputs from a door sensor or from a wireless key sensor. And airbag ECU could receive information from crash sensors and from seat sensors to detect while someone is sitting on it. And safety ECUs will receive information from a distance sensor or radars, which will detect if a car is approaching an obstacle too fast. Okay, so ECU communicates to the actuators when it's time. For example, when wireless key is pressed, ECU communicates to a door to unlock it, or when crash sensor detects a crash, ECU communicates to the airbags to deploy them on seats where someone is sitting. Okay, and next one is a base system or vehicle control unit. It's just big ECU, which does a lot of functions. It acts like a gateway computer in a car and controls all other ECUs. Note that on a previous slide, ECUs was pretty independent of each other and should be configured separately. And this vehicle control unit combines a lot of function in itself. This centralization has a lot of good consequences. For example, the over-the-air updates could be possible. Another part of automotive software is infotainment. Infotainment and ADAS. Infotainment head unit cluster domain controllers are the user interface of the car. So it displays driving information. It could be used to entertain the driver or the passengers, and it uses interfaces like audio, video, touch screens, and so on. And ADAS is Advanced Driver Assistance System. It's a system designed to prevent like accidents that are caused by human error. The next is tools, and that's a broad topic. Tools, it's software which doesn't run on a target, doesn't run on a hardware. It just helps to build the software. So it's code generation tools. It could be some emulators. It could be build system, packaging tools, and a lot of testing tools. So and probably some configuration tools. As you can see on these pictures, there is two workers trying to fix a ceiling while floating in a swimming pool on some platform. It looks totally unsafe, and that's not what we say about automotive development, since automotive is standardized by safe standards. And there is a lot of safety in automotive. For example, OEM and tier 1 vendors should obey and should align their solutions with ISO 26262 and SPICE. So ISO 26262 is about road vehicle and functional safety. It's just a set of standards for functional safety for vehicles on the roads, about electronic part. And SPICE, it's like automotive SPICE, if you are familiar. SPICE, it's software process improvement and capability determination. It's just a framework for management to organize projects in a proper way. Regarding the programming languages in automotive for ECU, so mostly is a C language. It's not just broad C, it's some subset of C, which is specialized by MISRA C. So it's a subset of NCC with a lot of language features banned, like dynamic allocation is banned and so on. AutoSAR Classic, it's basically a platform. It's a set of architecture and a set of tools that helps to generate a code according to that architecture. AutoSAR means Automotive Open System Architecture. So just architecture for car modules. And it generates a lot of code depending on the config you have for a particular car. So yeah, you heard me right. Configuration is on a compile time, and you have a static configuration while building a car. C++ is also used, for example, by AutoSAR Adaptive. It's limited by AutoSAR C++ guidelines, which is a subset as well, but it allows some dynamic code and some dynamic configuration. For example, the platform could link services and clients during runtime. C++ usage is rising since the autonomous cars popularity is rising as well, and a lot of image recognition libraries and frameworks are written in C++ as well. And assembler is used in ECU programming. For the base system, it's almost the same. The C++ and C used mostly, but it's a little bit different since the software isn't running barebone. It's running on the same platform. For example, AutoSAR Adaptive Platform and beyond probably. It has less generated code. It's still a base and have a lot of standards and guidelines. And it runs on a host operation system like Linux or QNX. And in infotainment and ADAS, C and C++ used as well as graphical user interfaces were built. For example, Qt, Python is used for code generation, for testing, and for data processing. There's a lot of data need processed. Part of code is generated as well, and some models are used, for example, MATLAB or Simulink. The tools in automotive, it's a broad topic. We have tools like AutoSAR tools, which does configuration and code generation. We have network design tools, since ECUs are connected in a network with some topology and need to be properly connected. We have code generation, we have build systems, and a lot of such build systems. Emulators, packaging tools, testing, prototyping, and CI. So all popular languages could be used here, since it's not executed on vehicles, like Perl, Java, and so on. Python is widely used in this section, since it could be used to easily prototype things and create. It's used in CI, it's used in automation, and it's extensively used in testing. I need to mention Robot Framework, which is a testing framework written in Python, and it's been used a lot. And a lot of automation scripts are used as well. Java and .NET could be used here to create tools for testing or configuring ECUs. And for automation. Even Erlang could be used in some case to test platform software, to obey a golden rule of testing, to test software in a language different from which was written. How car is programmed, creating the software? Software is based on AutoSAR, and part of it is generated from models. We have following life cycle. So you can see that this life cycle is similar as in typical embedded software life cycle, but it has some different parts. We have a programming part, obviously. After that, we have code generation. A lot of code is generated alone by some set of rules, by AutoSAR architecture or some models. Next, the code is being built and tested, and testing is a broad topic as well, since we have a lot of testing, like unit testing and integration testing, where components are tested for integration and working with each other. We have system testing, a lot of testing here. Next, the code is being packaged if tests are passed, uploaded to some storage where all the firmware is stored, and next it's fetched by some downloading mechanism to a probably external tester or some tool which can download the firmware to the ECU. And after that, ECU is being rebooted and started. How downloading software is performed. For modern cars, it performed mostly with over-the-air updates through Wi-Fi or 3G anywhere, and the firmware package is being downloaded to the VCU. So VCU acts like a gateway here and receives those packages, decides which of them should be flashed, and communicates with dependent ECUs. So communicating with their bootloader, flashing them, and so on. For older cars, procedure is a little bit different. Those cars are flashed on a factory or in a service. They doesn't have some over-the-air updates, and every ECU, or mostly of them, should be flashed separately. So external flashing tools connect to the almost every ECU which is needed to be updated, and initiate software update sessions. There are some issues that could not be connected, and other issues like acting like a gateways to forward the flashing procedure. And software download is a complicated procedure, and it usually takes a lot of time, probably 1 hour or even more, depending on the car. Let's return to Python with a brief introduction. So Python is the interpreted and object-oriented language. It's pretty high level. It has a lot of built-in data structures, which are pretty convenient. It has dynamic typing and binding. It has extensive library and really great package manager for those libraries. And it's freely distributed with no charges. And it has nice syntax, as you can see here. So pros and cons of Python. Advantages are Python is high level, so it's easy to implement some ideas. It has no compilation step, so it has fast edit, test, debug cycle. It has a great debugger, which can introspect the code deeply. It has a great test system, where everything could be mocked almost. It has no segmentation faults, just stack traces, which will lead you to the moment where code is failed, so it's pretty easy. And it has a lot of libraries available with the package manager. So Python could be executed almost on every operation system. It's portable. But it has some disadvantages. One of them is speed of execution, since Python is interpreted language. Memory consumption could be a con as well, and it has global interpreter lock. So if you would like to use some real multi-threading, actually you can, since only one thread could run on a time. So Python encourages to use multiprocessing, or probably different Python realization without this global interpreter lock. And Python rarely runs on a target hardware, so it's mostly suitable for tools development or for fast prototyping or some for algorithm testing. So we have those roles of Python in Automotive. It's mostly used in AI and in tools. In artificial intelligence, it's used for development system based on machine learning and dataset processing. So artificial intelligence becoming more and more important. In particular, well, a lot of data receiving is automated, and a lot of data should be processed. So Automotive is such place where extensive data is generated and should be analyzed. A lot of relevant libraries are available, and a lot of simulation and testing analysis is performed in the Automotive with Python. In a tools subset, Python is tool which can which can give you fast prototyping, which can align dev environment. So for embedded projects, a lot of tools are available to a developer, and all of them could be aligned to have a consistent development environment, and this could be done with Python. So Python could be used to build software and package it. Some software is could be built in a different ways. For example, if you have different boards and different configurations and different sources, like base system, like some user applications, like some middleware, and everything of this should be combined and packed as a software package. That could be a lot of logic, and Python suits these needs well. It's extensively used in CI and in test automation. So testing in Python is easy, since it could be configured to communicate with some hardware, to run some emulators, and so on. It's used for integration and system testing with hardware-in-the-loop rigs. So it's just a rig with the hardware which is connected to a probably CI system and could be flashed with a new firmware that is needed to be tested. So some Python scripts just being done. So hardware is being flashed and software is being tested on the hardware. It could be used for build process management. For example, if you need to make some build system, who would like to have a build system in 2022? Probably someone. And Python could be used to create that. For example, over the CMake, over the other build system, and so on. So it could be used for firmware packaging, and it could simulate various things. For example, if you developing some ECU, which depends on some external communication, Python scripts could be used for that, to simulate some inputs or outputs to those ECU. It used for code generation tools and for configuration management. And it could also be used for diagnostics. Okay. So, examples of Python in projects and repositories. We have a Python API for AutoSAR adaptive platform. So a lot of machine learning prototypes are written in Python. And AutoSAR adaptive enables to connect to their API with Python to be in a convenient environment. We have PyOBD. It's a car diagnostic tool which connects to an actual car or some test rigs and provides communication with it. We have Python API for a canoe or canalizer. Those models are from Vector and they can simulate or analyze the CAN bus. It's like a communication bus in the cars. We have some debugger modules from iSystem, pretty convenient one. We have a lot of libraries which are used, and robot framework. Okay, and if you would like to see real code examples of Python projects, you can follow this GitHub link and look at automotive and Python tags. So with live examples, it's like a lot of tools written in Python here, tools that used to communicate some interfaces and protocols used in automotive systems, handling the unified diagnostic services. So it's some diagnostic tools. Some emulators are available, like OBD emulator, and some processing libraries, which processes calibration and configuration parameters. We also have some tools which makes datasets evaluation, which could parse AutoSAR configs, its RXML config files based on which code is being generated, tools that convert some configuration, and even a speed estimation and collision prevention tool or driver coaching system. So thank you. This is the end of presentation. Let's move to a Zoom call, and after a couple of minutes I will connect and answer your question.